A school administrator will assign each student in a group of n students to one of the m classrooms, where we have been given a range of m and n, that m has to be between 3 and 13 and n must be greater than 13. So the number of students is greater than 13 and the number of classrooms is between 3 and 13. Is it possible to assign each of the n students to one of the m classrooms so that each classroom has the same number assigned to it? So here the question needs to be answered in the form of yes or no. But the question is quite wordy. So in every such question, it's really important for us to rephrase the question in the easiest possible format so that we can retain and we can work towards the question, the actual question. So here the question is asking, is it possible to assign each of the n students to m classrooms so that each classroom has the same number of students assigned to it? So let's quickly do an experiment. If we say that there are 20 students, can we assign 20 students in 4 classrooms equally? The answer is yes. Similarly, can we assign 20 students in 5 classrooms so that each classroom has equal number of students? The answer is still yes. And now the next question is, can 20 students be assigned equally to 6 classrooms? Then the answer is no. The reason is that 20 is not divisible by 6. So here the question is precisely asking, is n divisible by m? That means, is n upon m an integer or not? This is the clear-cut question that we should be able to arrive at. So that's one of the strengths if you can simplify the question into the easier format. Now, our objective is only to figure out whether the number of students is divisible by the number of classrooms or not. Now, let's look at the first statement and start judging the merit in it. The first statement says that it is possible to assign each of the 3n students to m classrooms so that each classroom has the same number of students assigned to it. So it only means that 3n is divisible by m. So 3n upon m is an integer. Now we have to find, if 3n upon m is an integer, can we ensure whether n upon m is an integer or not? So here comes a really interesting part, and that's the trickiest part of this question, and let me tell you, it's an official question. So let's take a few cases. In all these questions, our objective should be very clear, and the objective should be to prove that the statement is not sufficient. Which means I would like to bring in 2 scenarios, one in which n is divisible by m and scenario 2 in which n is not divisible by m, whereas in both the scenarios 3n should be divisible by m. So let me take one of the cases. That means I can take n equal to 20 and I can take m equal to 5 so that 3n over m is an integer because 3 times 20 is divisible by 5, and 20 upon 5 is also an integer. That means the answer to the question is yes. Now let's consider scenario 2. Let's take n equal to 20, but now since I want to bring the answer no, so I would like to take the values of n and m such that 3n is divisible by m, but n should not be divisible by m. That means I want to keep the highest common factor of n and m something greater than 1, but still I want to ensure that 3n is divisible by m. So what I'm doing is, I have 3 here and I have n here and m in denominator. So I would like to utilize the opportunity in such a way that m is a multiple of 3 and n is a multiple of a. So by doing so, a into b is not divisible by 3a essentially, because b may not be a multiple of 3, but 3 times of a into b is divisible by 3a. So I'm taking n as 20 and m as 6. That means the denominator I needed to pick a number which was a multiple of 3. By doing so, we see that 3 times 20 is divisible by 6, but 20 is not divisible by 6. The result is not an integer, so the answer to the question is no. And therefore, the first statement is not sufficient. The trickiest part of this question was to figure out the ways to prove that the first statement is not sufficient. Now, having understood the science behind why the first statement was not sufficient, now we can look second statement in even more efficient way. And yes, never to forget that we always have to choose the values of n and m which satisfy the given range. Now the second statement says that 13n students can be assigned to m classrooms so that each classroom gets the same number of students, which means 13n over m is an integer. So we start using this statement by the same intent that we had while solving the statement 1. But here we have to get this clarity, since I keep saying that GMAT does not give you any number that is meaningless. So here this 13 has a great meaning in it. You see, we already know that m is in the range 3 to 13. The first statement could have been proven not sufficient because the denominator could be taken a multiple of 3. But here the denominator m cannot be taken a multiple of 13 because m is less than 13 while 13 is a prime number. So 13 and m have no relation whatsoever. We can say the highest common factor or GCD of 13 and m has to be 1, and because of that reason, for 39 upon m to be integer, n upon m also has to be an integer only. We can try several values, but understanding this algebraic process, I guess, makes it more sensible. If you have understood the first statement, then understanding the second statement is clearly simpler. And therefore, answer to the question is definitely yes. That means the second statement is sufficient to answer the question. Having said that, we understand the answer to the question becomes option B. That means the statement 2 alone is sufficient, but statement 1 alone is not sufficient. It's a beautiful question, and I've also posted such question on GMAT Club. I think that also is worth giving a try. Thank you so much for watching this video.